Imagine, just for a moment, total pitch-black darkness. No Earth, no planets, no sun at all. Just an incomprehensibly vast, freezing void. Welcome to our explainer today. We're going on an epic 4.6 billion-year journey. We're going to trace the truly cinematic, violent, and honestly deeply beautiful history of our cosmic neighborhood. We're talking about going from a completely empty cloud of stardust all the way to the vibrant system of worlds we know today.
It is, without a doubt, the ultimate origin story. How on earth did we go from absolutely nothing to literally everything? Well, okay, let's dive into this. To really understand our beginnings, we have to transport ourselves way, way back in time. We need to look at a literal dark void of cold gas and dust, just drifting silently in space, waiting for a spark.
Chapter 1. The Spark of Creation.
Now, every great story needs an inciting incident, right? A moment of profound change. And for our solar system, that moment was absolutely explosive. Picture this. About 4.6 billion years ago, a massive molecular cloud, a staggering 65 light-years wide, was just hanging out in deep space. Previous generations of ancient stars had lived, died, and essentially injected all these heavy elements into this cloud. But it needed a push. Scientists hypothesized that a primal supernova, often nicknamed Catalique, exploded nearby. Bam! This titanic shockwave slammed into our molecular cloud, triggering a massive gravitational collapse. The cosmic seeds of our very existence had just been planted.
So the crucial question here is how this collapsing cloud actually behaved. The standard model for this is known as the nebular hypothesis. It was first developed way back in the 18th century by thinkers like Immanuel Kant and Pierre-Simon Laplace. As gravity relentlessly pulled all that gas and dust inward, the cloud began to spin and cool down, eventually flattening out into a massive rotating disk. Think of it kind of like a cosmic pizza dough. And the vast majority of that material, we're talking over 99% of it, was dragged right smack into the center.
Right at the center of that spinning disk, the pressure and temperature reached just unimaginable extremes. The crushing gravity became so incredibly intense that naked hydrogen atoms were violently forced together, actually fusing into helium atoms. This nuclear fusion released a frankly unbelievable amount of energy. Our young star, which was a T-Tauri star at the time, suddenly ignited, pushing back against that immense gravitational collapse to finally find a stable balance. Against all odds, our sun had brought light to the darkness.
Which brings us to Chapter 2, Building the Planets.
Okay, so the sun is born, but our solar system is far from finished. The obvious question now is, what in the world happened to all those spinning leftovers? The gas, the dust, the ice still orbiting this brand new star. To understand how the planets came to be, we have to understand the frost line. Think of it as this vital, invisible cosmic boundary. Close to the young sun, it was incredibly hot, so only the really heavy rocky and metallic materials could condense into solids. But if you traveled out past the orbit of Mars, the temperature dropped significantly. Out there, beyond the frost line, volatile hydrogen compounds like water and methane could actually freeze and remain totally solid. And this brilliantly illustrates why our solar system is split into two completely distinct families of planets. In the inner, hotter region, little bits of rock and metal slowly smashed together. They accreted over millions of years to form the terrestrial planets, Mercury, Venus, Earth, and Mars. Meanwhile, outside that frost line, the Jovian planets formed, Jupiter, Saturn, Uranus, and Neptune. Because ices were so abundantly available out there, their rocky cores grew massively and rapidly. That allowed their immense gravity to sweep up huge, thick atmospheres of leftover hydrogen and helium gas.
Now for Chapter 3, A History of Violence.
Let's see how this builds, because if you're thinking these planets just politely and quietly settled into their current orbits, well, actually scratch that. The early solar system was a chaotic, incredibly violent place. According to the widely accepted NICE model, the giant gas planets essentially went to war with each other gravitationally. Around 4 billion years ago, Jupiter and Saturn fell into a 2-to-1 orbital resonance. Basically, Jupiter orbited exactly twice for every single Saturn orbit. This created an absolutely massive gravitational shockwave. The resulting tug-of-war literally shoved Neptune outward, causing it to surge right past Uranus and plow straight into a massive disk of ancient icy debris. This sent an absolute frenzy of comets and icy bodies scattering violently in all directions, ultimately creating the Kuiper Belt and the incredibly distant Oort cloud.
And that violence certainly wasn't restricted to the outer solar system. Down here in the terrestrial zone, planetary bodies were colliding all over the place. The giant impact hypothesis tells us that the early Earth was struck head-on by a Mars-sized object. Imagine that for a second. That titanic collision was so powerful, it kicked a massive amount of Earth's mantle straight up into space. Over a long period of time, all that superheated debris coalesced, cooled, and came together.
The result of that apocalyptic collision is actually looking right back at you on this slide. When you step outside and see the moon, you aren't just looking at a pretty rock in the sky. You are looking at the scarred, frozen aftermath of the sheer violence that shaped our very world. It's a constant, hovering reminder of the incredibly chaotic forces that built our home.
And it turns out Earth wasn't the only victim of a giant impact. Take Uranus, for example. We were all taught that planets are basically like rolling spheres, right? Well, Uranus spins completely sideways. It's tilted roughly 90 degrees. Scientists firmly believe another titanic collision in the ancient past literally knocked the planet right onto its side. And because a Uranian year takes 84 Earth years, this extreme tilt means that for 20 Earth years at a time, one pole of the planet gets exactly 0 sunlight. That is total, freezing darkness for 2 solid decades.
Moving further out, we reach Chapter 4, The Outer Realms.
Let's leave the warmth of the inner planets entirely behind and venture out into the deepest, darkest, and honestly most mysterious edges of our cosmic neighborhood. What's really interesting out here is just the weird shapes of the objects lurking in the dark. Out in the Kuiper Belt, the New Horizons spacecraft flew past a trans-Neptunian object called Ultima Thule. It's 31 kilometers long and is shaped exactly like a snowman. It's what astronomers call a contact binary, just 2 icy lobes gently stuck together. Because it is so incredibly far from the sun, this quirking little cosmic snowman is essentially a frozen time capsule, perfectly preserving the exact conditions of the solar system from 4.5 billion years ago.
But here's the thing, the Kuiper Belt is really just the front porch of the outer realms. Beyond it lies the Oort cloud, this massive, spherical shell of icy debris. To really understand the sheer, incomprehensible scale of our solar system, just look at this number. The Voyager 1 spacecraft, which is traveling at over 38,000 miles per hour, will take up to 28,000 years just to exit the Oort cloud and truly leave the solar system. You, your children, and your grandchildren's grandchildren will be long, long gone before it ever even crosses that threshold.
Finally, we arrive at Chapter 5, The End of Our Sun.
We've seen the explosive birth and the frankly violent adolescence of our solar system. But as we know, every story has an ending. Let's fast forward about 5 billion years into the future. Our sun is currently in the absolute most stable phase of its life, but eventually that hydrogen fuel in its core is going to run out. When that happens, gravitational forces will compress the core, causing the outer layers of the sun to expand massively, transforming it into a fiery, terrifying red giant. It will consume the inner planets, which, yes, likely includes Earth. But fortunately or unfortunately, depending on how you look at it, our sun isn't massive enough to die in a dramatic supernova explosion or collapse into a black hole.
Instead, it will face a very quiet, slow death. The dying sun will cast off its outer layers, just puffing its gas out into the interstellar medium. And all that will be left behind is its exposed core, a cooling, glowing ember called a white dwarf. It'll be packed with totally unimaginable density into a sphere no larger than the Earth itself. And so the whole incredible story comes full circle. The heavy elements our sun forged deep in its core, along with the materials from the planets it consumes, will be pushed right back out into the dark void of space. They will drift as a cold molecular cloud, just waiting for another spark. The end of our solar system is really just the beginning for another. As you look up at the night sky tonight, you kind of have to wonder, billions of years from now, whose eyes will be looking back, standing on a brand new world built entirely from the ashes of ours?